Hi, my name is Dr. Deshawn. In this video, we are going to find the area of an irregular shape using the limit process and Riemann sums. Before we start with this example, I thought we would take a look at Riemann sums and some of the summation formulas that will be needed for this problem. So let's start by taking a look at a Riemann sum. So a Riemann sum expression, we have 3 times I goes from 1 to 4. When you're computing a Riemann sum by hand, all you do is start at this with the lower number, all inclusive, end at the top number. So you're going to plug in 1, plug in 2, plug in 3, plug in 4 to the expression. And then what do you do with those terms? We're going to add them up, because when you see the sigma notation in a mathematics class, you're going to just add things together. Now, what if instead of, we're just adding 4 numbers here. So the 4 numbers is no problem. But what if instead of adding 4 numbers together, what if we had to add 150 numbers together? Okay, that would be a little bit more tedious. So what we'd want to do in that case is we have some summation formulas. So the summation formulas that we'll utilize in our calculus problems in a moment. But your summation formulas, if you just have a constant, then the constant gets multiplied by the n. If you have an I expression in there, then you would substitute these formulas n plus 1 over 2 in for the I squared formula, I cubed. And these are the formulas that we'll be using in our example today. So if you can look here at this example I gave you, we could use the summation formula. Here's how the summation formula works. You can see that the expression has an I in it, so we're going to need to utilize our I formula. So, and it's being multiplied by 3. So you have 3 times, and so when you use your summation formulas, you're going to take the summation out. You're making a substitution. So summation of I comes out, n times n plus 1 over 2 is what goes in. That's proven to be true. And so you're going to take the I formula and substitute this in. Now, what do we use for n? Okay, n is the number that's sitting on top. So we would actually substitute 4 in. So 4 plus 1, there's 5 times 4 is 20. 20 divided by 2, 10 times 3 is 30. You can see whether you use the formula or you expand it out by hand, get 30 for your answer. So just a quick demonstration of these formulas and how they work. We're going to be utilizing these formulas inside of our area problems. So let's take a look at our area problem that we're going to actually compute. So we'll take a look at our area problem, and we want to find the area. Drew a diagram here, this green region right here. And so our function is 10 minus x squared, and the interval is from 1 to 3. We just want the area of this shape right here. So we are going to take the limit as n goes to infinity, summation I goes from 1 to n, the width times the height. Now what this formula does is it takes rectangles. We're between 1 and 3, we are going to put rectangles in this region. How many rectangles? We're going to put infinitely many rectangles in there, and we're going to find the area of these infinitely many rectangles. Width times height is how you find the area of a rectangle. We're going to start with the first rectangle, then the second, then the third, then the fourth. And what do we do with all these rectangles? We're finding the areas of all these rectangles, okay? We're going to use n rectangles and let n go to infinity. And what are we doing with all these infinitely areas of rectangles? We're adding them, Riemann sum, we're adding them together. And what it's going to do is it's going to converge for us onto the exact area under the curve. Here's how the formulas work. To compute the width, very formula driven. To compute the width, we're going to subtract the endpoints, okay? So it's b minus a over n, okay? So your left bound is a and your right bound is b. So to get the width, right, to get the width for this problem, we're going to take 3 minus 1 and put that over n. b minus a over n. 3 minus 1 is 2, so your width for this problem is going to be 2 over n. That's what the width is, all right? So far, we're going to compute the area of this region. So the area is going to be the limit as n goes to infinity. Summation, I goes from 1 to n. The width is 2 over n. That's what the width is, okay? So the width is 2 over n. And now we got to figure out what the height is, all right? We have a formula for the height. To compute the height, you plug into the function the left bound. A is the left bound, okay? So 1 plus your width is 2 over n times the ith interval. All right, now that expression needs to be plugged into the function. Be really careful. So the function is 10 minus our quantity squared. Okay, so that's what our function is. We want to take the x in the function and replace it with the 1 plus 2i over n. All right, and I like to off to the side over here expand this. So I have 10 minus, now I'm going to have to expand this in here, okay? So FOIL this out. So you end up with 1 plus 4i over n, when you take the outside and inside, plus 4i squared over n squared, okay? And then we want to distribute the negative sign. So you have 10 minus 1, that's going to be 9, okay, minus 4i over n, minus 4i squared over n squared. And here is what we need to use for the height, okay? So for the height, what do we have for the height? We have 9 minus 4i over n and minus 4i squared over n squared. Here's our height, okay? So here's how we set it up. So here's the width and the height based on our function, all right? Now, what I like to do next algebraically, I like to distribute, all right? So there's a lot of different methods of actually getting through the algebra portion of this, but I like to multiply it out. So I have the area, it's the limit, n to infinity, summation, I goes from 1 to n. When I distribute here, I have 18 over n, okay, minus 2 times 4, so that's going to be 8i over n squared, okay, and then 2 times 4, I have 8i squared over n to the third power. So I have this when I distribute my 2 over n to each of these terms, okay. Next step is to put our summation formulas from the other side of the board. Our summation formulas, do you remember what those are? So let's go ahead and put our summation formulas in. So you have the limit as n goes to infinity. Remember that when you put the summation formulas in, Riemann sum sign, that's when you can move this Riemann sum sign out of the way. Okay, so you have 18, every single term takes on a summation formula, 18 over n, this is going to be 8 over n squared, and that's going to be multiplied by our I formula, all right, and then we have 8 over n cubed, that's going to be multiplied by our I squared formula, all right. Now, what are these formulas from the other side? Well, your constant formula, you just, anytime you have no i's at all, it gets multiplied by n. Do you remember the I formula from the other side of the board was n times n plus 1 quantity over 2, all right? And then our I squared formula was n times n plus 1 times 2, n plus 1, all that's over 6, all right? So you're putting your formulas in, and then we want to algebraically simplify, evaluate all this, okay? So let's see what we have here. So we have the area. It's the limit as n goes to infinity. I have 18n over n for my first term. I see that the n's cancel. I'll leave them there for now, though. All right, let's see what I have for my next term. 2 goes into 2 once, 2 goes into 8. 4 times one of these n's cancels. I'll cancel those. So what do I have in the numerator? Distribute the 4, so I have 4n plus 4 in the numerator, and I have n in the denominator, okay? All right, and then let's simplify here. 6 and 8, 2 goes into 6 3 times, 2 goes into 8 4 times. One of my n's cancels, leaves me with an n squared at the bottom. Now expand here. Now be careful because you have the binomial times a constant out front. So 2n squared times 4, so that gives us 8n squared, okay? Outside, so you have n plus 2n, 3n times 4 is 12n, and then your last term is going to be a plus 4 when you distribute that 4, and you have 3n squared. All right, so here's what we have expanded. Now, it looks like we need to get a common denominator. Let's go ahead and get that common denominator so we can write this as one term in here. So we're going to take the limit n to infinity. We'll do that momentarily. What do I need for a common denominator? Okay, so common denominator looks like the 3n squared. Okay, so looks like I need a 3n squared for a common denominator. 3n squared for a common denominator. First term here, we've got an n. I left that there, right? So we still need a 3, and we need another n. So multiply numerator and denominator. So our new numerator, 18 times 3, that's going to give us 54n squared. Okay, second fraction, we have the n, we still here need a 3 and we need an n. So whatever we multiply the denominator by, same thing with the numerator, now distributes. So 3n times 4n, so you've got 12n squared plus 12n here. Okay, and then this term here, we have the 3, we have the n squared, so just bring down the numerator. So 8n squared plus 12n plus 4. All right. Now that we have a common denominator, let's go ahead and keep the denominator and combine our numerators, all right? So we're going to take the limit. I need to still write this down because I haven't taken the limit yet. take the limit as n goes to infinity, okay? Our denominator is 3n squared, that's what we have. What about our numerator, 54n squareds? And then take away 12n squared and take away another 8n squared. When you combine the n squareds, it looks like we have 34 of them left. 34n squared minus 12n minus 12n, so minus 24n. We have to distribute that negative sign, so be careful. And then there's a minus 4 there. Now take the limit to infinity. The powers are the same, so 34 thirds. 34 thirds, that's what the area under this curve is. The area under this curve is 34 thirds. Okay, and that's the exact area of the shaded region. The area is 34 thirds. This is how you would actually use the limit process, the Riemann sum, to compute the area of an irregular shape. So there's another way to do this later on when you do learn the fundamental theorem of calculus, but for right now, this is a lot of the theory behind why that works. It's so important to just get the understand the theory behind why all that works as well. So I hope this helps, and thank you so much for watching. If these videos do help, I would appreciate if you'd subscribe. And that's it. So take care. Thank you so much. Bye-bye.